Hello everyone, my name is Alejandro. I'm going to present you this work, and the title is Construction of an Ultraviolet Light Response Gene Signature to Predict the Prognosis of Uveal Melanoma. This project was made with Fundación Universitaria de la Andina and the Dynamical Business and Science Society and Universidad de Antioquia. So, as an introduction, uveal melanoma is a rare and aggressive cancer that arises from the pigmented cells of the eye, although UVM accounts only about around 5% of all melanomas. It is the most common primary intraocular tumor in adults. And there's a lack of effective systemic therapies. A few people have attempted to build prognostic genes expression signatures, and there are promising tools to predict the risk of metastases, and they can guide treatment decisions. However, clinical and histopathologic data should still be used in conjunction with gene expression profiling to make treatment decisions for this patient. And as you may know, ultraviolet radiation is a well-known risk factor for cutaneous melanoma, and recent studies have suggested that it may be important for uveal melanoma as well. So this is the method section. Basically, we downloaded the RNA-seq data from the TCGA corresponding to the uveal melanoma cohort that it's around 80 patients. And we also downloaded 158 gene list from the Hallmark UV Response UP database. And we perform a univariate Cox regression analysis for these genes. And after that, with the genes associated with survival, we perform a rich regression using this R package for survival associated gene that was around 64. And after that, with the genes that the rich regression assigned a coefficient, we estimated a risk score with the following formula. So we multiply the gene expression of each gene by the rich coefficient, and we had in total 11 genes with non-zero coefficients, so that's good. And after that, we perform functional enrichment analysis with the high and low risk groups. We also perform some candidate drug analysis, an immune microenvironment analysis using the XLR package, and we also try to associate this expression signature with clinical pathological features. And finally, we validate this signature with this cohort available in the GEO database, and the outcome of this cohort was metastasis-free survival instead of overall survival. So here are the results of the univariate Cox regression analysis of the UV genes, and you can see that these 6 genes are related to worse survival status, and that the hazard ratio are quite high, like from 5 to 8.5. And these other 5 genes are related to a better outcome. You can say that they protect against dying. And I'm showing you only these 11 because they are associated with survival, but they reach regression assign a coefficient, so they are important for prognosis. So we evaluated the performance of this gene expression signature using a Kaplan Meier plot comparing high risk versus low risk patients. And you can see here for the training cohort, which is the TCGA cohort, that the low risk patients tend to live more than high risk. And in the rock curve, you can see that for the 4 years estimate, the area under the curve is 0.86, which is really good. This is the validation cohort, and we see that the low risk patients also live more here, and the area under the curve for 2 years is 0.74, which is lower, but let's remember that for this one, the outcome is metastasis-free survival and not overall survival. So we perform an enrichment and drug sensitivity analysis, taking into account the high versus low risk patients with a risk score. And you can see here that there's a lot of pathways related to the immune system, such as cytokine-mediated signaling pathway, neutrophil migration, alpha-beta T-cell differentiation, and there are also some related to extracellular matrix and major histocompatibility complex, which is really interesting. And in this other plot, we have four drugs that show significantly lower IC50, and they might be useful for treatment of high-risk patients, and this could improve survival. And finally, we perform an immune microenvironment analysis due to the fact that the immune microenvironment appears to be really important for these high-risk patients. So we found really interesting differences in the immune populations for dendritic cells, hematopoietic stem cells, macrophages, M1 and M2, and also plasma cells. As a conclusion, the identification of genes responsive to UV light has implication for the prognosis and treatment, and this knowledge could aid in developing personalized treatment options and discovering novel therapies that target the pathways of these genes.